a large luncheon this last week, which celebrated the idea of sustainability and gave out a bunch of awards. And of course, her work is part of our inspiration, along with the board of directors. There are three of the four original founders are here, and a few of the others of the executive board here. So, Marie, thank you very much.
What I wanted to talk to you today about was to tell you why biomimicry is a science that we need to embrace, give you some overview of biomimicry, how we implement it, and what principles we use when we apply biomimicry to a project or process, and give some examples of how other companies and industries are using biomimicry, and then end by telling you some stories about how EPA and other federal agencies are using the science of biomimicry to solve environmental challenges. So the first thing we need to recognize is that as a species, we are the young ones. We're the babies of the planet. And if you took the entire 3.8 billion years of life evolution on this planet and put it on a one-year calendar, this is somehow how it would look. So it's not till February that organisms form up out of that primordial soup. So it took a few months of this one-year calendar of 3.8 billion years for just a few basic organisms to appear. And then in March, photosynthesis started, and it started oxygenating the planet, making it more hospitable to other organisms. And then we had to wait all the way until September before sex starts happening on the planet. And so in September, DNA was starting to be exchanged between organisms, and then the population of life on this planet really exploded. So it was all the way until December before we really started seeing other creatures on the planet. The reptiles, the fungi, the insects, birds, they all came out in December of this one-year calendar. And then on the summer solstice, we got a special gift. We got the flowers of the planet. And then on Christmas Day, it was a really bad day for the dinosaurs. They went extinct that day, December 25th. And just 12 hours ago, the predecessors of our species, our hominids, started walking on 2 feet. And it wasn't until just 24 minutes ago that we came on the planet. So we are the young ones. What we do in the next minute really will determine our survival. Will we be a sturdy survival on this planet, or will we just be a short-lived evolutionary blip because we haven't really address the problems of sustainability? And what we've done as a species is we've made a really bad systems error. We think that we are apart from nature, and we act that way instead of a part of nature. And the law is after us, the natural law, and it's hot on our trail. We have really broken a lot of rules of this planet, and we're in trouble. And so the more that we look to the 30 to 100 million species on this planet, is we can view them as our mentors. We can really fix the system error. And that's a pretty good ratio, you know, one species to 30 to 100 million elders. And so we have a lot to learn. And the reason biomimicry is so sustainable is because it follows the natural law. It follows life's principles. And organisms in nature, they create conditions conducive to life in everything they do, following life's principles. So nature recycles all materials, cultivates cooperative relationships, self-organizes, and we should follow those principles as well. And there's, out of all the organisms that have been on this planet, 99.9% have gone extinct. So nature has no problem getting rid of species. But the 0.1% that is left have really learned how to survive on this planet, obeying the operating conditions of the Earth, and we have a lot to learn from them. And biomimicry just isn't about making better stuff. It's about thinking differently, and it's about finding our place on this planet and humbling ourselves. So when Janine Benyos, who wrote the book Biomimicry, has anybody read the book? It came out in the mid-90s. When the book first came out, she went into a big box store and she wanted to buy the book. And so she looked in the engineering section and the nature section and business and design. She couldn't find it anywhere. And so she asked one of the store clerks, she says, well, where's this book, Biomimicry? And he said, what's it about? And she said, well, it's about living well on the planet. It's about using all the organisms as our mentor. It's consciously, emulating life on this earth. She says, it's about the technology of biology, or the biology of technology. And the store clerk said, look, lady, you've got technology and you've got biology. You have to choose one. And she realized that he was just talking about the categorization scheme in this store, but she realized that that's why we have such a problem. We've separated technology from biology, and we're biological creatures. And so we need to pay attention to that. And recently I was introduced to a really interesting book called Biology Re-Envisioned. And it's about the theory of what if biology was the basis for our scientific method instead of physics. So physics takes everything apart and looks at individual components. But there are emerging qualities that come out of organisms that arrange the same kinds of chemicals and the same kind of cellular structure, but in different ways. And so what if we looked at that as something special, as an emergent quality that comes out through those organisms, and recognize that as something of a true miracle? So when we talk about biomimicry, we call it the conscious emulation of nature's genius. And by conscious, we mean that we actively seek ideas from nature. And emulate doesn't mean we just copy nature. It means that we look at the deep design principles that nature uses to perform a function and apply those deep principles to our designs. And nature's genius recognizes that after 3.8 billion years of evolution, nature has figured out how to do everything that we want to do as humans, and do it in a way that fits into this natural world. So the first thing we need to think about when we think about biomimicry is we think about it as model, measure, and mentor. And model means that we get ideas from nature. We model our designs after these elders and these geniuses on the planet. Measure is we design with nature in mind, and we use nature as our measuring stick. And we ask the question, if no other organism on the planet is doing something, should we be doing it? And when the Gulf oil spill happened, I was riding the bus to work, and I was thinking, I'm going to get all my biomimicry cohorts together, and we're going to get a list of strategies that we can use to clean up this big mess. And then it dawned on me that there are no organisms that go 5,000 miles or whatever into the surface of the planet to get its energy source. There is no model in nature. So should we be doing that? And it also tests the rightness of our designs. And using the life principles of biomimicry, we can compare our designs with how nature designs things. And even if we're not following all the principles, it would give us an idea of where our design will have some problems in the future, because the designs that don't follow life's principles are the ones that are going to have some problem in the future. They're going to be unsustainable. And biomimicry as mentor means that we recognize and we humble ourselves, that we are not the smartest organism on the planet because we've done a really bad job so far. So maybe we need to really honor nature, and it's a new way of valuing nature. So we asked the question, what would nature do? And sustainability, as you all know, requires more than just another policy that we put out there. It's really a reframing of how we solve problems. And biomimicry is a way of seeking those sustainable solutions by borrowing life's principles, life's chemistry, and life's design ideas. So the first thing we recognize in biomimicry is that there are operating conditions on this planet that we need to abide by. And I've left some handouts at the front table that have all of life's principles, and it indicates where also includes life's operating conditions. So one of the first operating conditions is that everything on Earth is subject to gravity, sunlight, and water. And we use gravity either to stay on the planet, or we find strategies on how to defy gravity, like the giant redwood trees that can pump water way up into the tree. Everything in nature gets all of its energy from sunlight, except humans. And water is the solvent used in all chemistry, and it's also a way that nature transfers information around the planet. Another one of life's operating conditions is that life is subject to dynamic non-equilibrium. We live on a planet that is constantly changing. And only designs or organisms that can adapt and evolve as those conditions change are able to survive. And as humans, we build very rigid things with very controlled parameters. And if the conditions outside change, our buildings become obsolete and they don't adapt and evolve into those conditions. Life on Earth is subject to cyclical processes, and organisms on the planet use the dependability of those cycles like we do to live on the planet. The seasons, the moon, the sunrise, the changes of the season, those kinds of cyclical events. And that life is subject to limits and boundaries, and we've done a really bad job of recognizing that. And this blue dot on this globe is all the water on the whole planet. It's all the oceans, the snow melt, the ice caps, the rainfall, everything. So you can see that our water is very limited. The pink ball on the other side is all the air in our atmosphere. That's our entire atmosphere. So you can realize that there are really definite limits and boundaries of what we have to abide by. And biomimicry is really a tool that can contribute to many eco-design paradigms. It fits in with the cautionary principle, the natural step, cradle to cradle, you know all of those. And biomimicry just supports those ideas and those ways of looking at solving a problem. There's 3 levels of biomimicry. So in biomimicry, you can mimic the form of an organism, such as Velcro was invented based on the concept of the hook and loop of the burrs that attach to your pant legs when you're out walking in the forest. But those burrs are made with water-based chemistry, and they live in an ecosystem that supports that whole organism from the beginning to the end, unlike Velcro, which is made with chemicals, petroleum chemicals, and it really, once its usefulness is gone, it just goes into the landfill. So in biomimicry, it's not enough just to mimic the form of an organism. We need to mimic the process of how that product is made in the natural system and embed it in a system that we live in a whole ecosystem. How does biomimicry differ from other bio approaches? Well, bioutilization is acquiring the product or the producer. So I'm using the example of abalone. So in that case, it would be just a sustainable harvest of abalone. It would be bioutilization. Bioassisted means to domesticate the producer, like raising cows for milk, or in this case, maybe natural farming of abalone for food. And in biomimicry, we emulate the producer. So if we could emulate the way that abalone makes ceramics, which is one of the hardest ceramics in the world, and it's made in seawater at ambient temperature right next to the organism's skin. We heat, beat, and treat. To make ceramics, we have to heat materials to huge temperatures. So all of these are good approaches. They're just not biomimicry. Bioutilization and bioassisted. So let me give you some examples of how other companies have used biomimicry. So one of the concepts we see in nature is the concept of the spiral and the golden ratio. It's found everywhere in nature. It's found in many organisms. You can see it all over. And so there's a company called Pack Scientific who asks the question, how does nature move fluid? How does nature move air? And if you think about it, there's nothing in nature that has a propeller attached to it, and yet that's how we like to move air and water. And so Jay Harmon of Pack Scientific asked the question, how does nature move water? And looking at how it moves in an exponential spiral, like when you're emptying your bathtub. That's what water wants to do. So he invented a motor that will move water by starting it moving in an exponential spiral. And you can use this to mix very large tanks of water. It uses 90% less electricity than the equipment we use because it's doing what nature naturally wants to do, what it's been designed to do after 3.8 billion years. So here's an example. This motor will mix this entire tank of water. And this is what it replaces. So when we engineer systems, if we want our system to perform another function, we just add more stuff. We just keep adding more and more equipment. But in nature, it fits form to function. It does not add more stuff. It's a multifunctional design. So one of the things that Jay Harmon is looking at now is how does nature move air? And how we move air is we pull air into a space when we want it to have air. But in reality, in nature, nature pushes air. There's always a front behind nature pushing it. And so he's working to develop different kinds of fans now, based on that principle. This is the Eastgate building in Zimbabwe. And when the architect was building this building, he asked the question, how does nature cool? And in Zimbabwe, there's termite mounds. And termites, as you might know, they don't digest wood. They actually grow a fungus in their termite mounds that digest the food. And the fungus can only live if the indoor temperature does not vary by 1 degree, even though the outside temperature varies by as much as 40 degrees. And so the way termite mounds are stayed cool is there's a series of air canals that pull the air in through the termite mound. And depending on the location, these termite mounds can be very tall or they can be much shorter. And so using that concept and emulating that deep design principle, the Eastgate building was designed in Zimbabwe. It's a 200,000 square foot office building that has no air conditioning. And yet the indoor temperature stays constant throughout very hot times of the year. And it does it through these channels, these air channels that pull air through the building at night and naturally cool the system. And they're able to have an energy bill that's 10% of a typical office building size by emulating nature. Now in Colorado, we would not mimic a termite mound because they're not a species that lives here in this Colorado. But many of you are aware of the ConocoPhillips site on the old campus, Sun Microsystem campus. HOK, architectural firm, won the bid to redevelop that site, partly because the first thing they did was they put a biologist on that site for a month to study the natural conditions. And the keystone species of the prairie ecosystem is the prairie dog. And so mimicking the way prairie dogs keep their burrows cool, they design passively cooled air systems for the ConocoPhillips site. This is the bullet train. It's the fastest train in the world. It's in Japan. It goes over 200 miles an hour. And the reason it's called the bullet train is that the nose of this train used to be shaped like a bullet, the head of a bullet. And there was one problem. When it exited the tunnel, the differentiation between the outside air and in the tunnel caused a large noise, a clap. It sounded like a clap of thunder that could be heard over half a mile away. And so the engineer, the designer, was told to fix that problem. That was unacceptable. Well, the designer was an avid birder, and he asked the question, what in nature moves between two different substances without making a disturbance? And he thought of the kingfisher, because the kingfisher's life depends on being able to dive into a pool of water without disturbing it and catching those fish. So shaping the nose of the bullet train to mimic the shape of the beak of the kingfisher quieted the train, uses 10% less electricity, and goes 10 miles an hour faster. What about CO2? We're having a hard time with CO2 in the environment. But all the organisms on the planet use CO2 as a resource. And so Caldera said, well, could we use CO2? How can we make a really hard substance using readily available materials? And when you make a ton of cement, you emit a ton of CO2 into the atmosphere. And so mimicking the way coral reefs build their structure, Caldera was able to design a cement that by making 1 ton of cement, they actually sequester half a ton of CO2 as that. And hopefully it will be a pretty available building block once we learn how to pull it out of the atmosphere. And Department of Energy now is studying how human lungs remove CO2 and using those deep design principles to design filters that would do the same. Blue mussels have to live in a really turbulent environment. Their life depends on being able to stay stuck when ocean currents are very turbid. And so the University of Oregon looked at how mussels are able to adhere. And they found that there's 2 mechanisms that mussels use to adhere. They use a specific kind of natural-based glue, and also it's a structure that comes out of their body that also helps them adhere in these turbulent environments. So using a soy-based glue, they invented a process that will eliminate the formaldehyde used in wood products. And Columbia Wood Products use Pure Bond in all of their manufactured wood products and eliminated hundreds of thousands of pounds of formaldehyde, which off-gas for years after those products are put in a building. How do birds avoid a collision? So you have, I don't know about you, but lots of birds run into my windows no matter how many stickers I put on them. But asking the question, how do birds avoid a collision in nature? Birds never fly into a spider's web. And they found that spider's webs contain a chemical that reflects UV light, and birds see in UV. So a window company embedding UV particles in their window that we cannot see manufactures a glass that naturally just deters birds. They see it as if it's some kind of a web, as an obstruction. So what we do in biomimicry, instead of saying what we want, for example, you're building a building and you say, put an air conditioner in there, okay? What we do in biomimicry is ask, what do you want your design to do? What function do you want to achieve, and then how does nature perform that function? So you can see, with the example of the termite mound, how does nature cool? In zebras, you know why they're black and white stripes? They've been able to evolve to live on the hot plains in Africa because they have black and white stripes, and underneath the black stripes in a zebra are their sweat glands. So they absorb sun and they sweat, and under the white, there's no sweat glands under the white part, the white stripes, but that reflects the light, and a small air current is generated between the white and the black stripes, and the sweat glands provide the air, so they have a swamp cooler on their whole body. And so there are designers now who are trying to use that concept to develop building skins that would naturally cool. So what biomimicry does is it strives to emulate the general patterns and processes that are found in nature, and we call these life's principles. And life's principles is a set of principles that every organism on the planet except humans follow. because if they don't follow them, they go extinct. So it's been perfected after the 3.8 billion years of evolution. And I've handed out the list of life's principles, and I wanted to go through them with you really quickly. And when you came in, you have a card on your chair, and it has one of life's principles and the definition. And after this talk, I'm going to give a little game around whatever life's principle you have, so you can be paying attention here. So one of life's principles is evolve to survive. And that means continually incorporating and embodying information to ensure an enduring performance. Evolve to survive. And some examples of that are, we've used a lot of antibacterial soaps and products in our market, and so bacteria are rapidly developing organisms, and they've had to evolve to survive. And now we have bacteria that is resistant to our antibacteria. The democratic process is an example in this country of how humans evolved to survive. The democracy we have today is very different than it was hundreds of years ago because we've incorporated changes in our culture into our democracy in order to keep it alive. The strategies that nature uses to evolve to survive is nature replicates strategies that work, integrates the unexpected, and reshuffles information. Another one of life's principles is that be resource efficient with materials and energy. And you skillfully and conservatively take advantage of local resources and opportunities. There's nothing in nature that gets granite countertops from clear across the world for their home. Nature uses local, resource efficient materials. An example of that is the bones in a bird. In order to be light enough to fly, a bird incorporates materials only at areas where there is stress and leaves the rest of it hollow so that they are able to fly. And GM right now is developing a concept car based on that strategy and making it much lighter, much more gas efficient. Interface carpet is a good human example of that. They ask the question, how does nature adhere to a floor? Because they use glues to glue their carpet squares down, and it's a formaldehyde-based glue again. And they realized, after looking at a lot of different examples in nature, was that nature uses gravity to hold things down to the floor. So instead of putting glue on their carpet, they invented this small little square. It's about the size of a Post-it note, and it's called a tactile, and it just glues the four corners of the carpet square together, so it acts like a giant area rug. And then those carpet squares can be easily recycled, which they couldn't be if it was glued to the floor. And the strategies that nature uses to be resource efficient is nature uses a multifunctional design. Designs in nature do more than one function, uses low energy processes, recycles all materials, and fits the form of the object to the function that it needs to achieve. Nature adapts to changing conditions, so appropriately respond to the dynamic context, the dynamic non-equilibrium of our planet, and invest optimally in strategies that promote both development and growth. And some examples, one example is the Arctic hare. In the winter, it's white. In the spring, it changes from white to brown. It's modeled as the snow disappears, and then in the summer, it's brown. So it's able to adapt to changing conditions. A human example is our movie regime that we have been going through. You know, only companies that are able to adapt to the new technologies that are coming out are ones that are still in business. And so strategies that nature uses to adapt to changing conditions is to maintain integrity through self-renewal. Nature doesn't wait until something breaks down. Our bodies continually renew itself. Incorporate diversity and embody resilience through variation, redundancy, and decentralization. And many of our designs are not very resilient because we want designs to be efficient. So we eliminate redundancy from our designs. Another one of life's principles is to integrate development and growth. So invest optimally in strategies that promote both growth and development. And a nature example is the development of a human fetus. So the cells differentiate, they develop into different organs, and then those organs grow. When we design cities, if we don't invest optimally in both development and growth, we get schools that are overcrowded, or we get hospitals that can't serve the public, or roads that are clogged with cars. So the way nature integrates development and growth is combined modular nested components. Nature self-organizes, and nature builds from the bottom up. I mean, nature doesn't create a big sheet of leaf material and then cut out individual leaves. They create leaves cell by cell, builds from the bottom up. Nature is locally attuned and responsive. It fits into, it integrates with its surrounding environment. And we like to invent one thing for every purpose, but that is not the best or most efficient way to do things. And this is the Namibian desert beetle, and it lives in the Namibian desert where there is zero rainfall. And the way that organism is able to survive in that environment is that at the beginning of the morning, it climbs up until it reaches an area where the fog is really heavy. And there's small nodulars on the body of the beetle that condense the fog into water, and there's channels that direct the water into the mouth of the beetle. That's how it's able to survive. And so using that, emulating that design principle, someone invented these catchment bases for refugees that live in areas where there's either polluted water or there's not much water at all. And again, it's a multifunctional design. Once you get the fog and drink the water, you can use the piece of equipment for many other purposes. And so the strategies that nature uses to be locally attuned is using readily available materials and energy, use feedback loops, effective feedback loops, to find out what's going on in the local environment, leverages those cyclical processes that we were talking about before, and cultivates cooperative relationships. And we've had the impression that nature is survival of the fittest. Nature is very competitive. But in reality, competition costs too much resources, and nature is very cooperative. Nature only competes up to a very limited amount of energy expended, and then it walks away. It just says it's not worth it. So nature is much more cooperative than we are. And life uses friendly chemistry. All chemistry in nature is done in water. So it creates conditions conducive to life. And we already talked about the way blue mussels adhere, and how that strategy was used in the wood products industry. Another example is a snake, rattlesnake, kills its prey by poison, but by the time it ingests that prey, there is no poison left. All those constituents break down into benign materials. And just because we have this whole periodic table doesn't mean we need to use every element in our designs. Nature uses rare elements very rarely, and uses multiple other elements freely, like carbon and nitrogen. So nature does that by breaking down products into benign constituents, chemistry and water, and builds selectively with a small subset of elements, and not many of the rare ones. So the thing that I appreciate most about biomimicry is that it encourages biologists and engineers and designers and business people to work together. When I studied biomimicry, I studied with 4 disciplines: biologists, engineers, business people, and designers. And we had to work on all of our homework projects, and all of the work we did were in teams of those 4 disciplines, and that was not easy. I mean, we hear all the time we need multidisciplines to create sustainable designs, but to really work with other disciplines is very difficult. I'm a civil engineer, and the biologist, anytime I was on the team, I wanted the project done, I wanted it on time, I wanted to bring it in on schedule, and the biologist just wanted to study more. So we had a real tension between us, and I saw the value of additional study, and they eventually saw the value of completing the project and getting it in on time. But it was to recognize the value of those other disciplines and bring them into the mix. But mostly we need to quiet our cleverness. We need to be humble because we don't have the answers, and we are the young ones on the planet. And there's a web page, I don't know if any of you have heard of this, asknature.org. Has anybody used it or heard of it? So what the Biomimicry Institute is concerned about the patenting of nature's secrets, and that's what's happening nowadays. But if you put that information on the internet, you can't patent it. So the Biomimicry Institute received a very large grant to take all the scientific information that's already been done, all the research done on organisms on this planet, and reclassify it. Because right now, that information is classified based on the organism. And what Ask Nature does is reclassify it based on the function that the organism is achieving. So you could type in, how does nature desalinate? And you can learn how mangroves desalinate and how cells desalinate, or plants or penguins desalinate, because some use similar strategies, some use very different strategies. So when you identify the function of what you want to achieve, it's a verb, it's not a noun, you can put it into the search engine, and up comes this research that is already available about how organisms perform that function. And then out of those ideas, you can distill the deep design principles and see how they could help with your project. So I wanted to tell you a little bit about how we're actually using it. So many people are familiar with the whole story of the Cuyahoga River. It's a river in Ohio that caught on fire in 1969 for the last time, and actually was one of the catalysts to start the Environmental Protection Agency. Well, the people in the Cuyahoga River Valley are really tired of being the group where the river caught on fire. So the Cuyahoga River Valley is 4 different counties, and they have many of their services are together combined, the 4 different counties. So the county commissioners for the Cuyahoga River Valley got the biomimicry message, and they've studied biomimicry for many years, and they want to be the first place in the United States that uses life's principles as policy for land use decisions. So one of the projects we worked on was tools to help the Cuyahoga River Valley use life's principles for land use decisions, a declaration of interdependence. And this is what the Cuyahoga River Valley looks like. If you've never been to Cleveland, it's an eye-opener. So Standard Oil started there 250 years ago. They're highly industrialized, and they said there's no way that they're going to return this ecosystem to the way it looked 250 years ago. But their goal is to return the functions that were lost through development, and they want to repurpose their equipment and repurpose their infrastructure so that it functions like the original ecosystem, and that then they feel that their community will be much more sustainable. And for example, when we were working with them, they were putting in a bike trail that connected the Cuyahoga River with the Lake Erie. And we asked the question, well, what other organisms need a pathway between the Cuyahoga River and the Lake Erie? And could this bike path also serve as a migration route for organisms? Here's one idea of how we use life's design principles for water. So again, we identify the function in water. You want to collect water, store water, distribute and use it. And then you look at life's principles. Life's locally attuned and responsive. So how does that translate into collection of water? How does that translate? How does nature deal with water storage and water cleaning? And how can we use those principles in some of their activities, like redesigning their stormwater. HOK, one of the largest architectural firms in the world, they've made a commitment that by 2025 they will incorporate life's principles into the design of their buildings. And this is an example. They entered into the City of the Future competition, and they're developing environmental performance standards for their buildings, so that when you put a building in an ecosystem, you don't remove the functions. The building retains the ability to perform the functions that would have been removed if you just put a regular building there. So they're asking questions like, how much rainfall does this area get? How much goes into the stream? How much goes into the groundwater? How much is absorbed and released into the atmosphere? And they partnered with the Biomimicry Guild to submit a research grant to the National Science Foundation to actually invent a building skin that would absorb and release water at the same rate that the natural ecosystem does. Right now, HOK is designing and building an eco-village and training center in India based on life's principles as their first project of this type, and to develop how do you translate life's principles into architectural and engineering language. And they're looking at things. They had biologists study a very disturbed site. It was a 200-hectare site that had been highly disturbed in the past. And so biologists spent 4 months there looking, and this is in India where they're building it, looking at what does that ecosystem want to return to, and using those as their design parameters for the site. They've been trying to translate those design parameters into engineering and architectural language. So a normal ecosystem in that area had like 80 to 100 trees per hectare, so that becomes part of their landscaping plan. They discovered that when the monsoons hit, there's no ground that's bare in a natural ecosystem. So they have standard operating procedures that if you've disturbed a site and the monsoons are coming, here's what you need to do to cover it, because that's part of this ecosystem. They're looking at 80% of the seeds in that ecosystem are distributed by mammals. So where are the migration routes that need to occur so that those animals will naturally distribute those seeds? So in their City of the Future competition, they're trying to redesign Atlanta to be a sustainable area. So this is what it looks like today, but they want to redevelop it so humans can live there, but applying environmental performance standards to their buildings and designs, so that maybe it looks something like this. And if people have been to Atlanta, this is what it looks like coming into Atlanta, but here it is re-envisioned, with building skins that perform some of the functions. You have corridors for wildlife, you have natural areas, but you still have the functions that we want. We want good transportation, we want nice buildings, but we can do it in a way that fits into our planet. Recently I worked with the South Platte River watershed. They asked me to help them. They're a nonprofit group that looks at the South Platte River. And it's very impacted. You know, it used to perform many functions for humans before it's been highly developed. You know, and so now there's all these environmental problems, and they said, oh, Marie, what do we do about this? What do we do about that? They even asked me, do I think we should plant cottonwood trees there? Because it's a big debate whether they should plant cottonwood trees along the banks of the river or not. So first I said, asking a civil engineer whether to plant cottonwoods is not the best idea. But secondly, you know, what you need to look at is what functions have you lost in the South Platte River watershed? And how can you replace those functions? And is planting a cottonwood tree the best way to restore that function? That's the question you should be asking. And there's lots of people who are looking at this river, lots of biologists. And you should ask them the question, how does nature perform those functions? Because they know the answer. We just haven't connected the two together. It brings everything into a whole instead of individual parts. We use nature-based principles as a sustainability tool and work working with the national parks. It's a perfect application. They have facility managers that perform a lot of functions. It's like having a little miniature city. And they have biologists who have studied those ecosystems. They know how organisms perform in that ecosystem. So in working with the Great Sand Dunes National Park, they get about 300,000 visitors a year, and they have a huge amount of plastic drink bottles. And one of the things that I do in my job is I help federal agencies develop and implement sustainability plans. And they said, Marie, you know, setting up a recycling program, there really isn't even any recycling in Alamosa. It just doesn't seem like the best we can do. And most of our plastic recyclables are shipped over to China. I mean, is that really what we want to do? And so we asked the question, how does nature provide portable hydration in the San Luis Valley? And we looked at how organisms did that, and we developed a different system for providing hydration to visitors other than using plastic drink bottles. And we're waiting for funding to implement that. We also asked the question, how does nature respond to a soil disturbance? Because when they disturb some of the soil to put in for construction, for example, they get a lot of invasive species, even though they overseed with native grass. And so looking at how nature responds to a soil disturbance, they redesigned their system for a soil disturbance so that they could avoid those or reduce the amount of invasive species. Many of you are aware, yes?
I don't want to ruin the surprise, but how did you provide water to visitors to the
How did we
Great Sand
provide
Dunes?
portable hydration?
Yeah.
Well, again, we took a whole systems approach in looking at the problem. We didn't just jump to a solution and say, let's put in plastic recycling bins. So we put together a team of people, multidisciplinary, and we actually went to a remote site in the Great Sand Dunes and hashed this out with the organisms right there in front of us. And a lot of organisms in the San Luis Valley get their water by the food they eat. So that was out. That was a strategy that we couldn't really serve people watermelon from a vending machine. So one of the strategies we found is that there are no organisms that climb the dunes in the heat of the day, and that's when all the visitors climb the dunes. Right after lunch, they go to the top of the dunes. And so we talked to they redesigned how they present information to the visitors. So first of all, they're telling the visitors that. You know, no other organism climbs on the dunes at 2 o'clock in the afternoon in June or July. Maybe you shouldn't. So they started offering visitor programs and movies and other things that would entice the visitors to not go out on the dunes in the hot part of the day. We also found out that 90% of the visitors to the Great Sand Dunes don't travel more than 40 feet from their car. So we don't have to provide portable hydration very far. So that simplified it quite a bit right there. And then organisms, they seek shade during the hot part of the day. So the Park Service is trying to put up some shade structures, get the funding to put up more shade structures. And then nature recycles all materials. And in the San Luis Valley, they are able to recycle aluminum. And so they want to convert all of their vending machines, which is where all the drinks are served through. They don't have a concession operation, to the screw top aluminum. They found out that a lot of materials come onto their site from school visits. So they implemented a program where when kids bring their own water bottle, they get a sticker from the sand dunes, and if they don't bring their own water bottle, it costs them extra money to actually buy something. So it's a disincentive. So you know, those are kinds of some of the ideas that we had around that. So a lot of people know about BPA because it's in plastic water bottles, but not a lot of people know that it's on the surface of cash register receipts as well. And people that handle cash register receipts all day absorb the BPA chemical in their skin. And it's one of the toxic release inventory, the TRI, people familiar with TRI data? It's the top hundreds of chemicals that are very dangerous in our society, and EPA requires you to report the release of those. And BPA is one of the ones that always is high on the list. And so we said, well, as a demonstration, can we look to see how nature would help us solve this problem? And so what is the function we want to achieve? We want to achieve an instant color change because we want a carbonless receipt. And so we looked at nature and said, how does nature respond to a color change? It creates an instant color change. And we found 16 organisms that had an instant color change, and we were able to extract 3 deep design principles to how nature does that. And so we're marketing this information around to different universities, chemistry departments, and seeing if somebody wants to pick up the idea. The U.S. Forest Service is another good outlet for biomimicry because, again, they have engineers who perform functions, and they also have biologists who study it. And what the Forest Service decided to do as an initial introduction to biomimicry is when they're getting ready to publish documents, especially around sustainability, they have me go through and translate some of the words that they're using into life's principles so that the Forest Service starts to see biological language in their reports instead of other kinds of words. And they start hopefully reconnecting themselves to the resource that they protect, because many of the decisions made by the Forest Service are made in big office buildings. They're not out there sitting under a tree. So using biological language in their sustainability publications and other kinds of publications is starting to integrate those ideas back into the Forest Service. Right now I'm conducting a biomimicry workshop for local, state, and federal governments. We have 23 people who are enrolled in our biomimicry workshop. We do a series of 6 2-hour-long webinars, 1 a month with homework, and then we're going to do an in-person session at the Great Sand Dunes in September. And we looked at these 4 challenges. These were problems that people within these government institutions had. How does nature collect, distribute, and store water with minimal energy use? MSU is spearheading, Montana State University is spearheading that challenge around agriculture, because we're going to have to become extremely efficient with our water use in the West. How does nature communicate, and how can those strategies help us communicate about sustainability? How does nature spread information around? How does nature organize? In the federal government especially, we're being asked to implement sustainability, which needs a system that can adapt and evolve over time, because as you know, sustainability is this moving thing. We're constantly learning new ideas about it. But how do you develop an organizational structure in a very rigid bureaucracy? And so we're looking at how does nature organize, and how does nature, what principles do they use for that? And how do the front range species adapt to seasonal changes in climate? And can we use that information to develop adaptation plans to climate change themselves? And then the Boulder County and City Open Space wants to use information about the organisms to alert their users and have more respect in that mentor part of nature, valuing using as nature as mentor. So, does anybody have any questions or comments about this new science? You're all biomimicry enthusiasts now, right? Yes.
There's a field in material science called biomimetics. They understand the abalone shell, for example.
Right.
It's very clever. It's just very clever.
And there's a lot of information about that. This isn't something new that people just invented. We have, as humans, have been doing it for a really long time, and native cultures did it very well. They just didn't have the technology that we have now to be able to really understand the deep principles. Yes.
Thank you so much.
Oh, you're welcome.
Amazing. So, such an amazing concept. I have one question about the UV in the windows.
Yes.
First. Is that harmful to humans' eyes?
No, we cannot see in UV.
But, so UV rays, we're all told are very bad. We're all told that UV rays are very bad for us. They don't, obviously the lines in the window don't produce the same kind of wavelengths.
And I don't know the answer to that question. I don't know a lot of the details, but I would imagine it's not, the window's not emitting
Yeah.
UV. It's just that you can see it UV, right?
I would imagine it actually reflects it to
Reflects
the
it.
outside and actually protects humans on the inside even more.
Other questions or ideas, comments, thoughts?
Has this concept been tried on windmills? I think that's the problem with those windmill gardens.
There is some work being done on that. It's interesting. I was speaking earlier about Jay Harmon at Pack Scientific, and he is also looking, and this was a concept he told us over lunch and a couple of beers, so I've got this vague notion, but could you create a windmill out of puffs of air instead of having a physical blade there? That's kind of what he's studying. And don't ask me any more questions about it, but just disturbing the air and capturing the energy, because that's what a windmill does. It captures that force. And could you capture that force without a physical structure that birds would not run into?
I was curious, the word biophilia is a word that I had learned about. Do you work with anybody that kind of studies that and kind of the human interaction to these biomimic, I guess, strategies?
No, I really haven't. I don't. Does anyone here have any thoughts on that, biophilia?
And that's more like a psychological, sociological aspect where we feel more comfortable as a
Correct,
species
yeah.
in the presence of nature. But if we're using inspiration from nature to create technological things, I don't even know if we're going to be perceiving those things as nature. I know like one of the biomimicry things is using the reflection of the butterfly wings to create a screen
fabric.
technology that
Yeah,
doesn't
right. Oh, that's
have
true.
glare because
Right.
it actually uses reflection
Right.
to create colors. And we would perceive that as a technological thing, not a nature thing. So I think that, I mean, it'd be interesting to talk about this, but I mean, as how biomimicry affects us psychologically, but it seems like that's more like I like the green leafy stuff, and creating a building that absorbs the sunlight to create energy is not necessarily a green leafy building.
Or is it the disappearing of that line that's
Right.
going on?
But again, you can't just mimic one part of it. You need to mimic the form, maybe in butterfly wings, getting a more energy efficient screen, right? Computer screen or television screen. But then if you manufacture it in a really sucky environment with a lot of chemicals, and then you use it in a way that doesn't really fit into the natural system, you can't recycle it, it just ends up in the landfill, that's not biomimicry. So
Or
what-
biofilms.
Right. So what we use biomimicry more now is we do the first thing. We just mimic the strategy, but to mimic the whole process and the ecosystem.
I'd like to know what kind of, I guess, vision you see for what I consider to be kind of a waste of energy, golf courses. Could you address that? What you think, how that could be part of a sociological and environmental change that could benefit everyone?
But again, you'd
Denver
have,
Water's website, so we get
I didn't hear your
golf courses.
Denver Water, but I want a solution. I would like to see, or a higher consciousness
but
raising
if we
instead
could
of.
design a golf course and retain the functions of that natural system, okay, that would be the way to design. I'm not a golfer, but that would be the way I would look at it, or biomimicry would look at it, is what functions were being achieved by that piece of land. And when you want to put a golf course, our function is recreation. We want to achieve that function. So how can we achieve that function, but still let nature's functions to continue?
Expand the game of golf so you don't have the green fairway like you do in Scotland and the
Right,
Maritime Climate.
I saw a golf course. I'm trying to remember where it was, but
Rocks.
some Native American people designed a golf course. I'm trying to remember where I saw that just recently, and it was gorgeous. I mean, I don't even like
natural,
golf, but
yeah.
it was much more natural. It probably didn't, they didn't do it with biomimicry in mind, but There are other ways you can design a golf course. I'm
Considering
assuming.
most bars are built on top of it.
Not on top of a land.
That's not natural anywhere.
No, but what function was being achieved before you put a landfill there? And can we redesign it so that it achieves those same functions while we use it for our purposes?
There's a question about windmills over here, but I think I came across something, I can't remember where or when, but a design on a cylindrical windmill
I've seen
that
that.
kind of mimicked like an Asian seed pod that falls or something. So I
Interesting,
think that
right.
might, yeah.
To
I think
pick
that
up
might
that
be an example
energy.
of biomimicry, but I think that's where birds won't run into the blades or anything.
And there's another design, there's a company called Whale Power that designs windmills, and they copied the forward fin of a killer whale has ridges on it, and the aeronautics people said, well, that doesn't make any sense. The forward blade of a windmill has to be so smooth because it would cause, even insects on the blade causes drag and reduces airflow. But they found that these ridges on the front forward fin of the whale really help distribute the water, and so they started making ridges on the tops of their fan blade, and it gets 20% more electricity because it reduces the drag. Yes.
Yeah, the Roaring Fork Golf Club is a very progressive golf course. They use ecological design
Oh.
to actually to function as a lot of their maintenance. So
Great.
the trout pond is where a lot of the fertilizer comes from.
Oh,
And
wonderful.
things like that. And then typically in a lot of golf courses, the houses on the holes themselves are the most valuable. Well, at this golf course, the most valuable homes are actually off the golf course in the ecological reserves,
Wow.
where there's a lot of bird sightings and things like that.
So just a new way of thinking about things. Very good.
I'm voting for the termites.
All right.
I was just stopped dead by this Eastgate, and I'm just wondering if there's any direct approximations of can you tell us more about how those termite mounds function and the extent to which they could, as low-hanging fruit, apply to, let's say, new buildings? Do you know?
How that cooling system
Yeah.
can be used in
Well, we're designing roofs for the developing world, and one of the functions is to create a natural hyperbolic parabolic shape with a vent that creates this convection. And down in Haiti, it generated 20 degrees cooler temperatures. And so it's proven. And I'm just wondering, so is there any other basic elements that you think would be applied to, let's say, just small scale housing before you get to skyscrapers that would increase the updrafts?
Well, what I would suggest is that because nature is very locally tuned and responsive, so you look in the environment of Haiti and see how organisms keep cool in Haiti and how do they build their homes and how do they cool, and see if those strategies could help you design. Another way to look at it is to look at the deep biological principles of airflow, which I'm not familiar with, and see if there's some principle in there that we're working against in our buildings, like Pack Scientific did with the water, is how people are approaching that subject.
Try some earth tubes.
What's that?
Earth tubes.
Earth tubes? Like,
Yeah,
yeah, geothermal.
Air.
Well, yeah, one of the things is that air likes to create convection cells.
Yeah.
And so you can have shapes that with completely dead air, with any heat, it just naturally creates convection cells and you can create. I have to imagine that's how the termite mounds work. I'm looking at Eastgate, that's all I'm saying.
And I can give you some more detailed information about how the Eastgate building performs if you're interested. But again, it's a locally tuned solution, so it wouldn't work like it wouldn't work here in Colorado. We need to cool our buildings like prairie dogs, for example.
There must be some.
There's some,
you know,
I'm sure there
general
is some, right.
You talked about how indigenous cultures were a lot better at biomimicry than us. One way that we can cheat is to look, back 150 years before we, did away with a lot of these more primitive, what we call primitive, but more natural ways of doing things.
Absolutely.
Looking back to the way the people people might have lived cooler than hay, you know, 150
That's a good
years
idea.
ago.
Because, you know, we've been developing as a species for about 200,000 years. And for about 190,000 years, we lived right in nature. It wasn't until the advent of agriculture that we started separating ourselves from nature. And then we speeded it up really greatly under the Industrial Revolution. I mean, that really just, we just thought we were so clever. One thought was that adobe bricks are 12 inches, usually 12 inches deep. That wasn't just something that they just kind of guessed at. Burrowing animals, they burrow 12 inches below the surface of, that's optimal for energy flow and heat and cooling through a system. I mean, and when I do a biomimicry workshop, we look at the native cultures in the area where we're studying to see if we can get ideas. And actually the idea for the how does nature respond to soil disturbances came from some ideas that the native people had about seed saving and how they address that.
Any other questions?
Landfill was mentioned earlier, and I would imagine that's one of the biggest conundrums that we face technologically is which means our waste. Have you seen or heard of design principles in nature that help us
Would help us with landfills? The nature recycles all materials.
Great.
Our problem is nature can take as long as it wants to recycle materials. We want to recycle materials much quicker. So in that case, what I would recommend is that you look at how nature recycles some material, and if you have used the natural forms and processes for making your product, then it will break down into benign constituents. And then perhaps you could pull strategies from other organisms that catalyze reactions that you want to achieve. So you could combine strategies from different organisms to create a faster recycling of material, or, you know, the cradle-to-cradle idea.
Nature also uses materials very slowly as well.
Yeah, that's right.
So,
So
which
we
we
want things
don't
much
do.
faster, yeah,
Yeah.
that's, you know, we address other issues like, does nature have fun? Or, you know, nature doesn't care if organisms go extinct, and yet we're out to save the last person that's starving or has some problem. We have different values than a lot of the other organisms. So how does it, we have a lot to think about, and it's not just an easy fix. So let's real quickly go to your little game here. So everyone was given a biomimicry card with one of life's principles and the definition on the back. So I have the prize of a complete set of biomimicry life principle cards. And I'll tell you, I use these a lot. If I'm working on a project or a process, and I'll just leaf through these and say, does my design meet these? And I'll put on one pile where it's not meeting and one pile where it is, and try to incorporate more of these principles into whatever I'm working on. So who can tell me some way that you use that life's principle, or that you could use it in your work or your personal life? Who has an idea? A way you use that life's principle in how you live or how you work or how you could use it. Yes?
Breakfast, lunch, and dinner.
What's your life's principle?
Maintain integrity through self-renewal.
You
Persist by
renew
constantly
yourself.
adding energy.
Okay, you got a good one. Here you go. There you go. How about someone else? Yes.
I have cultivate cooperative relationships,
Okay.
find value through win-win interactions. I have a ecotourism adventure travel company and do trips in West Africa rather than competing with local companies.
All right.
Against my, against ecotourism.
Sorry.
We partner with the best local companies.
Very good. You cultivate those cooperative relationships. Good. One more idea? Yes.
I have built from the bottom up, assemble components one unit at a time. One of the things that I do, along with my friend here, Ryan, we do some natural building using materials on site, cob construction, that sort of thing. And I've been assembling some urbanite. We're going to be putting that as a foundation from the ground up and building cob on top of that.
Very good. Very good. Well, good job. Okay, well, I left some handouts on the table about life's principles. Take one if you have questions or comments after this talk. I left some of my business cards up here with my contact information. So I'm with the federal government, I'm here to help.
We invite you to stay around and network for as long as you like, enjoy some beer. We invite you to join us next month. I was just reminded tonight that we've been doing this for over 3 years, increasingly successful. Tonight, of course, the university students are all conspicuously absent because it's finals.
And lots of other people at the Rockies game.
And the other ones are at the Rockies game, and they'll all be back on the first Tuesday of June. We invite you to come back then. So Marie, thank you very much. Wonderful.